Hey guys, Hayden here again from Alarm System Store, and today we're going to be going over all of the different terminals, the wiring terminals that you'll find on the IQ Pro alarm system. So I've covered quite a few of these in previous videos, like with specific modules, you know, how do you connect this, how do you connect that. However, I haven't done a full overview of all the different terminals, so that's what we're going to do today. Now, if my IQ Pro looks a little bit different than yours when you first get it, it's because I've taken this cover off. Basically, this goes right here over top of the green board there. I take that off on mine when I go to wire it because of the screwdriver I have. It's not very long, it's kind of stubby and wide, so it's hard to get down in the terminals and actually tighten them. You can take that off, just be careful with the black wiring that's up here. Make sure you don't knock anything loose or unplug it accidentally, because all that does have to stay connected for the IQ Pro to work properly. So take that cover off, just be careful. However, it does give you more room to get into the terminals you do need to mess with. So we're going to be starting on the left, and we're just going to be going all the way to the right. I'm basically just going to show you how to wire up each individual type of device. So we have the transformer, the battery, have a siren we're going to hook up. Keypads and modules all get wired the same way, so I'll explain that when we get there. I also have a door contact and a motion we'll be connecting. So to start, on the very far left is your 18-volt DC positive and negative terminals. So that's going to be for your transformer. This transformer here that comes with the system is an 18-volt transformer, and it basically doesn't come with a wire, so you have to take an 18-gauge wire, connect it to these two terminals, you'll see them marked positive and negative, and connect it to the board following polarity. So in our case, it is better if you can put terminal ends on your wiring. However, I don't have any available right now, so I'm just going to use open-ended wire, which works just fine as long as you do it correctly. However, on the transformer, we're just going to stick this in, and you want to get it, here I'll show you. Underneath the screws, there's these little plates that hold the wiring tight if you get it up under there. And so you want to flip the transformer kind of upside down so that you can get the wire underneath the plate, and then you want to tighten it down. So once you have it wired, it will look like this. I always use red on positive and black on the negative, just because that makes sense for low voltage wiring. However, just make sure you keep polarity, like I said. Now, that's going to get plugged into an outlet whenever we are ready to power up the system. However, you don't want to do that until you have all of your other wiring connected. So you'll just take your positive and negative, and you're just going to stick those in the open terminals here and tighten them down. Now, like I said, you do want to use 18-gauge wire for your transformer. You'll also want to use 18-gauge for your sirens. So this siren here, since it's just a little demo siren, I just have 22-gauge connected because I didn't have any available 18 that would work for this purpose, so I just connected up this 22. However, it's the same concept. It's got a positive and a negative, and those are the next two terminals that you'll run into on the IQ Pro. So you'll have the bell positive and the bell negative right there. So you just connect your positive and negative to the siren, and then back at the panel, follow polarity, and connect the positive and negative there. Now, if you have a very short wire run, like I would on this siren, you do want to use a resistor on that terminal as well. Bell circuits are supervised, which means that the system looks for resistance to see if anything's connected. So if you have a longer run to your siren with 18 gauge, it will most likely provide enough resistance to clear that. However, the system does come with a 1K ohm resistor that you can stick on that bell circuit if your wire is too short. So if you plug this in and once you power up the system, you're getting like a buzzing noise or like clicking or anything like that, stick that resistor on there and that will clear that up. So the next terminals that we're going to run into are the core bus. So the red, black, yellow, and green here. So those four terminals are going to apply to all modules on the system. So that would apply to all wired keypads, zone expanders, power supply modules, and PGM expanders. So On all of your keypads or zone expanders, any of your modules, you will have a set of terminals that are red, black, yellow, and green, just like you have over there. Keypads do have an extra terminal here. You can ignore that. I talk about it in my keypad video if you want to check that out. But for just connecting it to the system, you just need these 4. So it's pretty straightforward. You just connect red to red, black to black, white to white, and green to green, or yellow to yellow instead of white to white. Depending on the manufacturer of the wire, you might get a white yellow wire, or you might get a yellow one. But anyway, so that is what your modules will look like wired up. Now, like I said, that's also going to apply to like zone expanders, and with the core bus, you can parallel your wiring. So basically what that means is each module can either be directly connected to the main board using those 4 terminals, or you can basically chain those by just running them in parallel, which means you'll have red, black, yellow, and green at the core bus to the first zone expander, red, black, yellow, and green, and then another wire going from the core bus on this zone expander to the next one, to the next one, to the next one. However you want to do it, totally up to you. You basically just have to have those 4 wires chained back to the panel in some way. So once you have your core bus modules wired up, then the next set of terminals are going to be the aux1 and aux2 positive and negative set of terminals. So it's 4 terminals, aux1 positive and negative, aux2 positive and negative. So these are basically used for powered devices. aux2 does have a specific purpose when used with PGMs, so we'll get into that in just a minute, but essentially powered devices such as motions, glass breaks, CO detectors, things along that line, which are going to require both a power connection and a zone connection, you'll connect to aux1 positive and negative. Now, if you need, additional space, if you can't fit all your power wires for your sensors in aux1, you can plug them into aux2. It shares the same 700 milliamps that are offered by the main board, so you're welcome to utilize both as you see fit. However, one thing to keep in mind is PGMs here are going to need the aux2 positive terminal here. So PGMs are outputs on the system. I do have a video that basically goes over everything you'll need to know about PGMs on the iQ Pro. However, just remember when you're wiring that if you plan to use any PGMs, such as like PGM2 for powering smoke detectors, leave enough space in aux2 positive for the positive wire of that connection. So moving on to the PGMs, the iQ Pro always comes with 4 PGMs on the main board. So you'll see them here, PGM 1, 2, 3, and 4. So they are only single terminals. Now normally you would need both a positive and a negative for power. However, PGMs are negative switching outputs, which means the PGMs themselves are the ground terminal for the device that you're trying to power. So I have a little piezo siren here. It's basically a little chime siren. You can use it with like keypad sounding, or if you wanted an additional sound to go off like when you're arming your system or anything like that, you can set this up. However, if I was going to wire this into a PGM, I would wire the negative wire into PGM 1, for example, and then the positive wire is going to go into aux2 positive. So that provides the actual power to the device, and PGM1 just switches to ground whenever that device needs to be activated. So keep that in mind if you're wiring any PGM devices. PGMs are all programmed within the installer app, so like I said, go check out that video if you want to see how to program it. However, this is how you would wire anything that goes to a PGM. Moving on from the PGMs, we have all of our zone wiring. So in this plastic cabinet, you'll have zones 1, 2, and a common between that is shared between zones 1 and 2, 3 and 4 with a common between, a common or ground, 5 and 6 share a common, and then 7 and 8 share a common. Now, on this plastic cabinet, as you'll see, there are already wires connected there. So that goes to this tamper switch here at the top of the cabinet. So that tells the system whether or not the actual cover for this cabinet is on or not. Now, you can remove that and you can actually change that zone to be something else if you want to. Totally up to you. However, if you want that cabinet tamper to be available, it's already set up by default, so just don't mess with it. You can still use zone 7. You'll just share that common, so you'll loosen up, the common terminal there, slide your other wire in, and then you're good to go. So if we were going to wire up a door contact, for example, we would take a 2-wire strand, just like I have here. Now, let me get a little bit longer one, sorry. Here, we'll use this one. So you would take a 2-wire strand. So if you only have 22/4, just fold back a couple wires, like I'm doing here, or you can snip them, whatever you want to do. But with door contacts, you only need 2 terminals, because they are just normally open or normally closed switches. In this case, these would be used in a normally closed fashion, so you'll just wire it to the door contact itself, like I'm doing here. And then you take your other 2 wires, and those are going to go directly to a zone terminal. So let's say this is the front door. We'll just put that on zone 1. So normally you would have the yellow wire as the zone wire, and then you're going to use green as the common or the ground for that circuit. Now, there really is no polarity difference on these, so it doesn't matter a whole lot. However, that is standard wiring if you want to follow it. On the sensor, there's obviously no positive or negative because it's not polarity sensitive, so it doesn't really matter how you connect it, just make sure both wires are connected. Now, if you're using resistors, keep in mind, I'm not going over resistors in this video, but if you wanted to use a resistor, you would connect the resistor at the sensor, not in the panel. So putting resistors in the panel itself does nothing. It completely obliviates the need for resistors because the system isn't supervising the circuit. The resistance has to be at the end of the line, which is why they're called end-of-line resistors, so that the system can supervise the wiring in between the panel and the sensor. So as this is set up here, it would just be normally closed. So you can set that up in the panel if you wish to. You do have the option in the system to use either end-of-line resistors or just have a normally closed or normally open circuit, whatever you want to do. So that would be the door contact wiring. And if you wanted to wire up a powered device, we'll use zone 2 for this motion detector. And the zone wiring is going to be exactly the same. So all motions are going to be a little bit different, so I'm not going to show that side of the wiring. Check the manual on that if you want to see it. But essentially, there will be the power wiring, which is going to be connected to red and black, and then there's also going to be the zone wiring, so it'll be like NC and C or NO and C, whatever type of motion you have, that's going to vary a bit, but you'll essentially do the same thing when connecting that to the panel. Just wire the yellow to the zone terminal, and then loosen up this common terminal for the ground for that zone connection. Now, like I said, with the power wires, these are going to be connected to aux 1 positive and negative. So red I always use as positive, so that's going to go to aux 1 positive, and then the black is going to go to aux 1 negative. And you'll do that for any power devices you have. You can use devices like these DT600s if you want to. It's basically just a fancy terminal splitter. So you put in, let's say, the red wire here and the black wire here, and then you get 6 red outputs, positive outputs, and then 6 ground outputs. So, or inputs, whatever you want to call them. So you would just connect all the reds to one side and then all the blacks to the other, and then you can just plug this directly into the system, and that way this one device is powering 6 different devices off of just one connection to the panel. That can reduce the amount of wiring that you actually have connected to the terminal bus on the main system. It might make your wiring a little cleaner. So the only thing I haven't covered so far is the battery wiring, which is pretty straightforward, but this is the cable that comes with the system. On one side it's got this little white connector, and then on the other side it's got 2 little quick connect terminals for spade terminals. So with the white, that goes to the top left of the blue board up here. So if I had the white portion on here, it would be just to the left of the white portion, the white cover. But there's 2 prongs here and a little clip. So on this connector, you'll see that there's a little clip right here, and you just want to match that up with the clip on the main board. Slide that on, and you're good to go. Now, on the battery side, batteries are always going to have a positive and a negative. So red is always going to be positive, black is always going to be negative. So usually the batteries have little, color code like this, but otherwise just look for the positive and negative indicators there. Red is going to slide onto the battery on the positive, and black is going to slide on the negative terminal. And that is it. So the battery, once you get everything else wired, you can put the battery in here. It normally sits down in like this, or you can turn it, whichever way, kind of cleans up the wiring as best you want it. But that is all the wiring you'll need to know on the iQ Pro, unless you plan to have a wired Ethernet connection. So the iQ Pro has a built-in cellular and IP communicator. For IP, you can use Wi-Fi, or you can use a hardwired Ethernet connection. If you're going to use Wi-Fi, you just program that whenever you're programming the rest of the system. If you want a wired connection, though, you'll basically just run an Ethernet cable in, and it plugs in right here. So just feeds in from the side, clicks in right there, and you are good to go. But otherwise, that is all the wiring terminals on here. Now, if you have other modules, those will have their own set of terminals. They're all going to follow the same principles that I just covered there. So zone expanders are going to have a core bus, and they're also going to have 8 zone terminals, just like you would see here. Power supply modules, they're going to have a core bus so that it connects to the main system. And then they'll have a set of terminals for power out to your devices, or some of them have additional PGMs you can use. Those all, like I said, will have manuals that show the wiring for those different devices. However, as for the iQ Pro itself, that's all you really need to know. So hopefully for those new to alarm systems that purchased an iQ Pro, that gives you a good overview of how everything's programmed. Like I said, there's no way I could ever tell you, in one video, if you want to connect this type of device, connect it this way. There's way too many configurations. Just remember, modules always connect to the core bus. Zone sensors that are not powered basically just take up a single zone. Powered devices, powered sensors, are going to have a power connection to the aux terminals and a zone connection for the open-closed circuit. So other than that, I don't think there's any more specifics I could cover, but otherwise, if you guys have any questions, by all means leave them down below and we'll answer as best we can. If you don't mind, leave a like and subscribe, and I will catch you guys on the next one.